Hello, glad you could make it. Now, in the last video that we were watching, we were learning how to look at a curve and find out what the equation of a tangent line to any point on the curve was. And now what we're going to do is switch it up slightly, and instead of finding equations of tangent lines, we're going to find equations of normal lines. And the goal being that you will find the equation of a normal line to a function at a given point. And so I'll talk you through that process, and part of that process is going to be defining what a normal line is, and so I'll be doing that right now. And we're going to start this kind of the same way that we did the last video, where I've got a function y equals f of x, and this we're going to say is the curve of that point, or sorry, of that function y equals f of x. Now let me use the graph over here to explain to you what a normal line is. All right. A normal line has a very specific relationship to a tangent line. And so it's relevant when you're talking about a normal line to talk about a point of tangency like we were doing before. So let's pretend that point right there is a point of tangency, and that this is a tangent line. And we'll say that the coordinates of that point of tangency are a, comma, f of a, just like they were in the previous video. Okay? And again, that's the tangent line. Well, what a normal line is simply a line that intersects a curve and is perpendicular to the tangent line at a particular point. All right? So this would be the normal line to this function y equals f of x at the point x equals a. Right here. And as I said, the normal line is simply perpendicular to a tangent line at a given point on a curve. Okay, and so when we're trying to write the equation of the normal line, it's going to work the same way as it did with the tangent line. The only difference being that the slope of the normal line is different than the slope of the tangent line is, right? And since those lines are perpendicular to one another, you ought to know the exact relationship between their slopes. Remember that the slope of the tangent line, we said, is always going to be found by just finding out what f prime of a is. And then also remember that when two lines are perpendicular, their slopes are opposite reciprocals of one another. And so if I want to show here that the slope of the tangent line, of the normal line, is the opposite reciprocal of that of the tangent line, well, then I'm going to write that like this. I'm going to say the slope is equal to -1 over f prime of a. Because remember, the reciprocal of a value, to write the reciprocal of a value, you simply put 1 over that value. And then we wanted the opposite reciprocal, so we could put -1 over f prime of a. It's going to be the slope of the normal line. And with that in mind then, here's how you go about writing the equation of a normal line. You, of course, first have to know what the slope of the normal line is, and I just got done telling you that the slope of the normal line, let me fix that, at the point x equals a is going to be given by the opposite of 1 over f prime of a. And then if we're looking at our point slope form of the equation of the normal line, well, it's still going to go through the normal line is still going to go through that same point of tangency. It's still going to go through the point a, comma, f of a. So our y1 is still f of a, and our x1 is still a. And then again, this right here is the slope of the normal line. So y minus y1 equals m times x minus x1. That's how you go about writing the equation of a normal line. Now I'm going to show you one example of that in this video. And we'll do that here with this function, f of x is equal to the x plus 2 squared. We're going to write the equation of the normal line to the curve of that function at x equals -3. Well, if we're going to write the equation of the normal line when x equals -3, one of the things we have to know is what is the point of tangency for this graph whenever x equals -3. So let's go ahead and do that. I'll plot this point here. Not that the plotting of it's going to help me figure out what the coordinates are, but it'll help you see anyway. And that point will be -3, comma. And then we've got to figure out what f of -3 is. That's what's going to go right there. Now when you're trying to find the y coordinate for the point of tangency, you plug in the x coordinate for that point into the original function itself, right? And so we have f of negative 3 equals negative 3 plus 2 squared. That's negative 1 squared, which is positive 1. That's the y-coordinate for this point of tangent C. And so we already know most of what we need to know in order to write the equation of this normal line. We already know a point that it goes through. It goes through the point 3, 1, so we know the equation will be y minus 1 equals something times x plus 3, since that's a negative 3 there. And that something will be simply the gradient or the slope of the normal line. And we said we could find that by doing negative 1 over f prime of a, and a always represented the x-coordinate for the point of tangency. So 1 over f prime, negative 1 over f prime of negative 3. And of course you recall that f prime of negative 3 would give you the slope of the tangent line right there. And so the negative reciprocal of that will give us the slope of the normal line at that point, negative 3, 1. This is the line that we're writing the equation for right there. Now, in order to find this value, we need to find out what f prime of x is. So let's do that. And you'll notice that instead of writing x plus 2 squared, I went ahead and squared that binomial so that I could write it as a sum of power terms that I know how to take the derivative of. And then we'll go ahead and take the derivative, and we'll get f prime of x equals 2x plus 4, and then the derivative of that constant is 0, so just 2x plus 4. And now we can figure out what f prime of negative 3 is. It'll be 2 times negative 3 plus 4. That's negative 6 plus 4, negative 2. That's the slope of the tangent line. And you can often abbreviate the slope of the tangent line with this notation right there, the slope of the tangent. And then to find the opposite reciprocal of f prime of negative 3, we're just going to take the opposite reciprocal of negative 2, aren't we? Positive 1/2. The product of the slopes of the tangent lines and the normal lines always has to be negative 1, and they always have to be negative reciprocals of one another. And I showed you how to abbreviate slope of tangent. You can abbreviate slope of the normal line this way. And it's the slope of the normal line that we need to include in this equation because we're writing the equation of the normal line. So now we figured out enough to know that the equation for this normal line is going to be y minus 1 is equal to 1/2 times x plus 3. So now you know that a normal line is simply a line that is perpendicular to a tangent line at a given point on the curve of a function, and you know how to write the equation of the normal line. All right, excellent work. I'll see you back another time.